A closed cylindrical can is to contain a volume of 6,400 pi cubic centimeters. Find the dimensions of the can that minimizes the area of metal to be used in its construction and state the area. So we're talking about a cylindrical can. So if the radius is r and the height is h, the volume is pi r squared h. We're told that that is 6,400 pi, and therefore pi's cancel, and we end up with, I'm going to write this as h equals 6,400 over r squared, and I'm going to call that equation 1. I think we're going to need to use that information, possibly in that form. We might need to rearrange again. What about the surface area? Well, one thing it tells us is that it's a closed can, which means it has a top and a bottom. So we've got 2 pi r squared for the top circle and the bottom circle. The curved surface of a cylinder, something you should know, is 2 pi r h. And very briefly, that's because if you take a sheet of paper, roll it into a cylinder and then roll it out again, and you'll find that one side is the circumference of the cylinder and the other side is the height. So what we want to do is minimize S given this. We can't differentiate yet because we have two variables. Now this is a common mistake made by students. You can only differentiate once you're down to 1. But I can use this to go in here. And so S is going to be 2 pi r squared plus 2 pi r, 6,400 over r squared. So that's going to be 2 pi r squared plus 6,400 times 2 is 12,800 pi divided by r, because that's cancelled with that. And therefore S is equal to 2 pi r squared plus 12,800 pi r to the negative 1. So we want to minimize that, so we need to do ds dr. And that is going to give me 4 pi r, take away 12,800 pi r to the negative 2, which is 4 pi r, take away 12,800 pi over r squared. Now, because we're doing, just going to tidy that up, because we're doing calculus here to find a minimum, we need ds dr is equal to 0, and that means that 4 pi r take away 12,800 pi over r squared is equal to 0, which gives me that 4 pi r is equal to 12,800 pi over r squared. Pi's cancel. 4r cubed is equal to 12,800, which gives me that r cubed is equal to, sorry, I just did it on the calculator, 3,200, which I don't recognize as a perfect cube. So for now, I'm just going to write that r is the cube root of 3,200. And I think I have a cube root button on this calculator. Indeed I do. And so that is approximately 14.7 centimeters. Okay, so what about the minimum value of S? Well, on the calculator here, R is my last answer. So I'm going to do 2 times pi times my last answer squared plus 12,800 times pi divided by my last answer, and that gives me, let's give that as 4,093. Square centimeters.